Hello everyone, good day, wonderful welcome. Today we will see how to understand the mass spectrometer results. Anyone can think what is mass spectrometer and what is the use of understanding its results? To answer these questions, anyone like to develop their own molecule to cure diseases or to make new material. Understanding the mass spectrometer results will be very useful to test the synthesized molecule or to know the already existing molecule. In the solar system, whatever it is, living or non-living things, all are made up of clever arrangement of molecules. These molecules in turn very clever arrangement of elements called atoms. Big brain humans might be took lots of omega-3 fatty acid. They analyzed all the atoms and arranged in a specific order which is called a periodic table. If anyone understands very well how the atoms are arranged in the periodic table, they are on the right path to estimate the existing molecule. Let us look some examples. Lipido, Plavix, all the drugs are composed of atoms like oxygen, hydrogen and many more to make a single molecule. All these drugs are used to cure diseases. Not only to cure disease, the molecules can be used to make computer chips, optical switching, display technology and many more smart materials. If anyone can understand these molecules, they can make their own molecules. Mass spectrometer is an instrument can be used to understand the atoms and molecules. In this instrument, the test sample converted into gas phase, then ionized and accelerated. Further, these atoms or molecules deflected by electromagnets and detected in the detector. High molecular weight samples deviated less fall on the right side of the graph. Low molecular weight fall on the left side of the graph depends on their molecular weight. Let us look at the anatomy of the mass spectrometer results. The highest peak is called the base peak. The molecular ion peak called the parent peak indicated by M+. M+1 peak is called the isotope peak. Example 1. Let us see the molecule contains single carbon atom methane CH4. The molecular mass of the carbon isotope 12 is 12 and the carbon isotope of carbon 13 is 13. Molecular mass of the hydrogen is 1. It is very important to know the abundance of the isotope. The carbon is mixed with carbon isotope 12 and carbon isotope 13 with the abundance ratio of 100:1.1. When we analyze this sample in the mass spectrometer, the M plus and M plus 1 peak must indicate the ratio 100:1.1. Example 2. Let us see the molecule contain two carbon atom ethane CH3CH3. The probability of the carbon isotope of the molecule is listed and the percentage of the molecule is calculated as 100:2.2. When we analyze this sample in the mass spectrometer, the M plus and M plus 1 peak indicate the ratio of 100:2.2. Let's see the graph. The x-axis is indicating the molecular weight and the y-axis indicating the percentage of abundance. When the M plus peak is 100% of the single carbon molecule, the isotope of the M plus 1 peak is 1.1%, which is in turn indicating the presence of single carbon in the sample. Now question. when the M plus 1 peak is 6.6 percentage compared to M plus peak is indicating what? If you think the sample should contain 6 carbon, then it is right. Let's analyze the M plus 1 peak. When we look at these graphs, the y-axis is indicating the abundance, the x-axis indicating the molecular mass. The M plus 1 peak indicates 2.53 percentage and the M plus peak indicates 46 percentage. This 46 percentage is equal to the 100 percentage of the carbon, and we have to calculate what is the percentage of M plus 1 peak compared to the peak M plus. After calculating the percentage of M plus 1 peak by the formula which indicates 5.5, that means the sample contains 5 carbons. Example 3. Let's see bromine. The bromine isotopes are bromine 79 and bromine 81, and its molecular weight is 79 and 81. The abundance isotope bromine 79 is 50%. Similarly, the bromine isotope 81 also 50%, and its ratio is 1:1. When we analyze these samples in the mass spectrometer, the M plus and M plus 1 peak must indicate the ratio 1:1. Another example of the molecule contain double bromine CH2Br. The probability of the bromine isotopes in the molecule is listed and the percentage of the molecule is calculated as 1:2:1. When we analyze the sample in the mass spectrometer, the M plus, M plus 2, M plus 4 peaks must indicate the ratio 1:2:1, and the M plus 1, M plus 3, M plus 5 peaks indicating the isotope of carbon 13. Example 4. Let's say chlorine. The chlorine isotopes are chlorine 35 and chlorine 37. Its molecular weight is 35 and 37. The abundance of the isotope chlorine 35 is 75%. The abundance of the isotope chlorine 37 is 25%, and its ratio is 3:1. When we analyze the sample in the mass spectrometer, the M plus and M plus 1 peak must indicate the ratio 3:1. Another example, the molecule contains 2 chlorine CH2Cl. The probability of the chlorine isotopes in the molecule is listed, and the percentage of the molecule is calculated as 9:6:1. When we analyze the sample in a mass spectrometer, the M plus, M plus 2, M plus 4 peaks must indicate the ratio 9:6:1, and the M plus 1, M plus 3, M plus 4 peaks indicating the isotope of carbon 13.